Hey Julian, let's see, I got your email about getting the triangle to work here. Let's see what we got so far. Alright, we got some square motion. I like how it drops like that and then bounces. We got the ball. Ball looks good. And the triangle bounced off the ball that time. Let's see. Yeah, it's going a little bit off on the side there. Okay, so let's see what's going on there. Let me kill this guy. So, let's take a look at your triangle class here for a second. So what you want to pay attention to here is you're doing this test, right, to make sure of where your x position and your y position, that they're in range. The thing is, you want to check and see how you're actually drawing, how you're actually using the x position and y position to draw your triangle. So if you go down here, I think it's down here, yeah, to draw, you got your x points and your y points. So for this guy, you have 3 x coordinates: x position plus width divided by 2, x position minus width divided by 2. So already you got something going on here. You can see that this first x here is in the middle, in between these two, right? Because this one's plus half the width and minus half the width. So when you're comparing your x position, you're comparing the middle of the triangle. I'll show you a picture in a second what I'm talking about. And then with your y position, you have the y position. So this, and then these two plus height plus height. Yeah, let me bring up a picture here. So the way to look at this is, you remember the coordinate system starts at 0, 0 over here, and it gets bigger in the y direction. As it gets bigger in the y direction, you go down. And as you get, so if you're adding a positive number, you're going to go down this way in the y direction. And if you add a positive number to x, you're going to go in this direction. And if you subtract from x, you go this way. So the 3 points you're using to determine your triangle in the triangle class is x position, y position, which is right here, this point, and then x position minus width over 2. So if the width is from here to here, right, then this x position minus the width over 2 is right here, right? That's x position minus width over 2. And y position plus height, if this is the height of the triangle, then if this is y position, then y position plus height takes you down here, and subtracting off width minus 2 brings you right to this point. So this point is x position minus width over 2, comma, x position plus height. That's this point. So if you want to check to see if this point is hitting the side of the wall, you need to think, am I going to use x position or am I going to use x position minus width over 2? And the same thing going on this side, right? Am I going to use x position plus height, plus width, or am I going to use x position plus width over 2? Okay, because you want to use this point to check bouncing against this wall, right? Okay, and so the y position and y position plus height, those are the same for the triangle and the square, I would say, right? And but the square, I would think, has like x position over here and then x position plus width over here. So I think that's why the triangle acts differently. So you have to write check things a little bit differently for animation. Okay, so I think if you keep this picture in mind, where your X position and Y position are relative to the triangle, this top point here, and then your leftmost point over here is your X position minus width over 2 is the farthest X that you have to the left, and the farthest X you have to the right is your X position plus width over 2. All right, so I think if you keep that in mind, you'll be able to figure out how to rewrite your animation method so that or your change position method, I'm sorry, so that it checks things correctly. Okay, so see if you can figure it out, and work on it for a little while, and if you can't get it, then shoot me another email.